Hi everyone, we're Team 4 Per4mance Methanol. Our group is all graduating seniors in the Cami 470 Senior Design course. My name is Kaushal Amin. For our senior design project, we were given a task of converting pipeline quality natural gas to high purity methanol product. For our group, our initial natural gas feed was about 51,000 pounds per hour, and goal was to produce 74,000 pounds per hour with 99.85% methanol purity. Based on our design, we were able to actually produce 75,000 pounds per hour with 99.86% purity. So our design is it works. It meets our specifications. Location of our plant is along the Delaware River in Philadelphia, which is a very beneficial location because it allows us to have access to a wide variety of resources and also the wide talent base due to the large population of Philadelphia and the many surrounding colleges and suburbs. As I just talked about it, the location is right along the banks of the Delaware River, which is one of the big advantages is that we get fresh water from the river, and that water may need to be purified depending on its use in the process. But I think that having the river right along the bank is very beneficial, and also that also gives us a river transportation and railway transportation, just being in a big city of Philadelphia. So in our presentation today, Stacy will focus on the plant design. Garrett will be mainly focusing on the economic analysis, and Alan will do safety and the environmental factors, and then I will return to the conclusion and the recommendations.
Hi everyone, I'm Stacy. As Kaushal said, I will be presenting our overall process design today. As you can see here, this is the basic block flow diagram of our entire process, and as you can tell, it's kind of confusing and it's quite a lot. But it can be broken down into three main processes. First, the removal of the contaminants. Secondly, the production of the methanol product. And finally, the purification of the methanol. So in our first step, the removal of contaminants, we needed to remove sulfur and mercury from the system because they are corrosive to the metal components in the system, can poison catalysts, and are also hazardous to one's health. So that it's better to remove them at the beginning of our process. So for our sulfur adsorption, we use monoethylamine as our solution to absorb the hydrogen sulfide. And then for mercury, we used an activated carbon bed in order to absorb the mercury. In both of these adsorbers, we were able to remove 100% of the contaminants because the adsorbents were so effective at removing the contaminants. So with our design, we designed these so that both of the adsorbers would be able to operate for an entire week before needing to be regenerated. So whenever they did need to be regenerated, there was another adsorber of each type in parallel in the system so that we could have continuous process flow of our natural gas feed. For our second step, we did the production of methanol product. So the production of methanol first began with the steam reformer, which converted the hydrocarbons in the natural gas feed into carbon monoxide and hydrogen gas, as shown by the reaction here. In our steam reformer, we added steam to the hydrocarbons, and then it converted it into the carbon monoxide and hydrogen gas, which is also known as syngas. After the steam reformer, though, we needed to remove the steam that was unreacted in the steam reformer, so we had a knockout drum that condensed the steam into water and removed most of the water from the system, and that prevented the water-gas shift reaction from occurring. After that, the syngas products and a little bit of carbon dioxide that was in the system was then sent to the methanol synthesizer. In the methanol synthesizer, methanol, ethanol, and methyl formate were formed, and then we had a lot of unreacted reactants. Well, really, the only thing we wanted here was the methanol product. So the unreacted reactants were recycled back into the methanol synthesizer in order to increase our overall plant conversion. And then the methanol, ethanol, and methyl formate products were sent to the distillation columns in order to begin the purification process of the methanol product. So in our purification step, we had to use 3 different distillation columns, because after 2 distillation columns, we were not getting the purity that we needed. As shown here, we were only getting a 99.62% purity, and we needed that 99.85%. So we added a 3rd distillation column. In our 3rd distillation column, we were able to have a product that was 99.86% purity and producing methanol at a rate of 75,394 pounds per hour, which exceeded our overall goals and allowed us to meet all of our specifications that we needed to for our project. So based on this design that I have just presented to you, Garrett will now be discussing the overall economic factors of our plant.
One of the most significant costs of our plant is the initial capital required to build our plant. Included in our capital costs are equipment, catalysts, and site development. As you see in this graph, the equipment capital costs are spent the most expensive at $133.8 million, and the utilities are least expensive at $34.1 million. The OBL costs are the second most expensive costs, and it includes items such as site development, product and raw materials storage, and environmental cost factors. The miscellaneous costs include different items such as catalysts, startup, and shutdown, and other costs that are needed during the construction phase of the plant. The operating cost of the plant should be approximately the same for each year that the plant is operating at full capacity when adjusted for inflation. The utilities are the most expensive at $34.1 million. However, this cost will vary over time due to changes in the prices of electricity and natural gas used for the fired heater. Changing natural gas prices will also change the cost of the natural gas feed that is converted in the plant, so the total raw material cost will change over time also. However, the approximate cost breakdown shown here should stay fairly proportional to one another throughout the lifespan of the plant. When operating at full capacity, the plant is expected to receive $82.56 million per year from selling the methanol product. Shown here is the comparison of the methanol product revenue with the capital and operational costs. Due to the fact that the profits exceed the operating costs, the plant will make money during its lifespan. However, the revenue is negated by the large capital costs that are required to purchase all the items needed to build the plant and also construct the plant. Overall, the plant is not expected to have a positive cumulative cash flow over its 15-year lifespan. However, the plant would be able to break even if the price of methanol were increased by just 1 cent per pound. When the price is increased by 2 cents per pound to 15.5 cents, the plant would break even and also begin to make profit during its 12th year of operation. Overall, the plant has a net present value of negative $139.1 million, and after-tax rate return of negative 3.5%. Having a negative net present value and rate of return indicates that investing in this plant would not be a very good investment because it would lose money during its lifespan. The favorability of this investment could change if the natural gas and utility costs decrease while methanol prices increase, but that would require further price forecasting to determine if it truly would be a profitable investment. I will now be handing it over to Alan, who will discuss safety and environmental concerns of the plant.
The safety of employees is one of the company's main priorities. Employees will be required to wear adequate personal protective equipment depending on the work environment they are exposed to. General PPE includes flame retardant clothing, face masks, hard hats, safety goggles, earplugs, gloves, and steel-toed boots. Since most of the compounds used in the design plant are flammables, no employee will be allowed to smoke on plant property. Moreover, equipment will be bonded or grounded in order to prevent or reduce any spark that could be a source of ignition. The design plan has numerous controllers and valves that will increase the overall safety of the plant. The distillation columns will have temperature, pressure, flow, and level controllers. These controllers will help keep the temperature gradient in the column, also will prevent the column from overpressurizing, and will also keep the liquid levels constant at all times, mostly. The reformer will have flow and pressure controllers in order to make sure that the appropriate amount of steam is going into the reformer, and also to make sure that there's no overpressure. Finally, the pressure, bypass, and direct valves will be used throughout the system. The pressure valves will be used on units with pressure controllers in order to prevent any overpressure in any of the closed systems. Also, the bypass and direct valves will be used in several heat exchangers in order to prevent any overheating in case any high temperatures are found. As of yet, no environmental assessment has been conducted. Before constructing the plant, biogeotechnical investigations must be conducted to determine the surface and subsurface soil conditions, as well as sampling should be done to test groundwater. By knowing the conditions, the environmental conditions of the plant's location, the company will be able to better assess the risk levels of any spill or leak, and also monitor the changes or conditions over time. Also, doing the sampling of these different environmental factors will also determine whether or not there are other contaminants already present in the area, for example, lead. Okay. During the startup and shutdown procedures, the methanol product quality varies, and it will be flared from the system. During these flares, some of the methanol will not combust, and such emissions must be regulated. During the flare and purge from the recycle, carbon dioxide will also be released, and such emissions will need to meet permit requirements for the company. The design plant will also generate wastewater from the water distillation column and flash drums. Before discharging the wastewater to the Philadelphia sewer system, the wastewater will be treated on site to make sure that it conforms to pretreatment standards. The discharge temperature, pH, and quality of the water will be monitored closely as they can affect aquatic ecosystems. The company is planning to solicit the services of Environmental Resources Management, which is a consulting company dedicated to help industries comply with air and water permits, as well as local, state, and federal regulations. ERM will also keep track of our annual emissions and will help to make any design modifications to increase the productivity or improve the plant emissions. Based on the information that we have presented to you, I will hand it to Kaushal, who will give you guys the final conclusion and recommendations for the plant's design, operation, and construction.
So Stacy focused on the process design, Garrett focused on the process economics, and Alan focused on the safety and environmental factors. So as Garrett mentioned earlier, the negative present value and negative 3.5% rate of return indicates that building this plant is unfavorable investment at the current methanol price at this time. On top of that, due to the volatility of the natural gas market, an increase in natural gas prices could make this project investment more unfavorable very quickly. And as such, we would recommend the company to analyze the natural gas forecast very carefully to determine whether or not the natural gas prices will negatively or positively impact the plant during its lifetime. the company should also analyze methanol market price. By increasing the price by 1% per pound of methanol product, we saw that the plant could break even and make a profit during its lifespan. And as such, if the methanol market price is expected to increase by a substantial amount in the near future, building this plant will be profitable and, in fact, be a good investment. Finally, if building this plant is deemed to a green light and to go ahead, we first recommend completing soil and water samples of the build site to see if there's any cause of concern. And after such, the plant design should make sure to include all the safety measures to protect the plant and its employees. And finally, we recommend that a plant design that we have presented to you today be used because it can be profitable under appropriate conditions, safe and effective at producing the desired methanol product.